In this video, we will look at questions from our worksheet on Newton's laws of motion. We will focus on applying Newton's second law in the form F equals ma, where of course F represents the resultant force acting on the body, m its mass, and a the acceleration on the body. Now, the first question we look at is question number 2 from our worksheet, which says that two forces of magnitude 30 newtons and 40 newtons, which are perpendicular to each other, act on a body of mass 25 kilograms. Find the magnitude and direction of the acceleration of the body. So as customary, we try to represent the situation on a diagram, and we apply Newton's second law of motion and the third law if necessary. So let's represent the situation on a simple diagram. So we're told that two forces of magnitude 30 newtons and 40 newtons act, which are perpendicular, act on a body of mass 25 kilograms. So let this be the body. All right. So the body of mass 25 kilograms. So let it be mg. So we have two forces acting on the body, which are basically perpendicular. So we're going to let one force act vertically upwards and the other act horizontally. And these two forces are acting at right angles. So let this be the 30 Newton force and this be the 40 Newton force, right? So what we're required to do is to find the magnitude and direction of the acceleration on the body. So basically what we will do is to find the resultant of these two forces. Now we can do that by basically completing our vector triangle or our parallelogram, whichever case may be. So we complete that. This would be 30 newtons. So the vectors essentially run tip to tail. So if you draw it like this, the vectors run tip to tail, and our resultant, and this would be our resultant, let's call it FR, right? So this would be the resultant of these two forces, and let's say it acts at some angle theta to the horizontal or to the 40 Newton force. Now these two forces are acting at right angles to each other. So by now you should be familiar with a right angle triangle with one side 3, one side 4. Then these triangles are normally of the sides in the ratio 3, 4, 5. So therefore, by Pythagoras' theorem, basically we get that FR squared is equal to 30 squared plus 40 squared. And so FR squared is equal to 900 plus 1600. So FR squared is equal to 2500. And therefore this means that the resultant force is equal to 50 newtons. Alright, so as expected, because this is a right angle triangle with sides in the ratio 3 to 4, then the hypotenuse of course must be 5, and that will always be a right angle triangle, right? So the magnitude of the resultant is equal to 50 newtons, and we must now find the angle theta. So we have theta, and we have the opposite, and we have the adjacent. We found the hypotenuse, but let's use tangent of the angle. So tan theta equals opposite over adjacent, and so we get that tan theta is equal to 3 over 4 or 0.75, and therefore theta is equal to the tan inverse of 0.75, and so theta is equal to 36.9 degrees. Right, so theta is equal to 36.9 degrees. Now the question, it did not ask for the resultant force, it asked for the acceleration, and it also asked for the direction of the acceleration. But what we know that is whenever there is a resultant force acting on a body, then the acceleration must be in the direction of the resultant force. So we found the magnitude of the resultant force, and we've also found the direction, and this will also be the direction of the acceleration. So the acceleration of course will be in the direction of the resultant force. And so now we can say that the resultant force acting on the body, Fr, is equal to ma, which means that the acceleration A is equal to the resultant force divided by the body's mass. So this gives us 50 newtons divided by 25 kilograms which gives us 2 meters per second squared. And so therefore we can say that the acceleration A equals 2 meters per second squared at 36.9 degrees to the 40 Newton force. Right? So A is equal to 2 meters per second squared at 36.9 degrees to the 40 Newton force. Right? And there we found not only the magnitude but also the direction of the acceleration on this body. Right? So that was question 2 from our worksheet. We'll now look at question 3. Now question 3 says a body of mass 5 kilograms is pulled along smooth horizontal ground by means of a force of 40 Newton acting at 60 degrees above the horizontal. Find A, the acceleration of the body, and B, the force the body exerts on the ground. So we'll read the question one more time and we'll take the information that we can from the question. So a body of mass 5 kilograms is pulled along smooth horizontal ground by means of a force of 40 newtons acting at 60 degrees above the horizontal. And as customary, we try to represent the situation using a simple diagram. Right? So let this be our body. Let this be the body which is being pulled along smooth horizontal ground. Right? So we're told that it is being pulled by means of a force of 40 newtons acting at 60 degrees above the horizontal. So if this is the horizontal, then this force is acting at 60 degrees. And the magnitude of the force is 40 newtons. So it's a 40 newton force acting at 60 degrees to the horizontal. Right? Above the horizontal. They want us to find the acceleration of the body and also the force the body exerts on the ground. Now, the first thing we must do is to basically try to establish other forces acting on the body. There's always going to be the body's weight, which always acts vertically downwards, and that is basically the body's weight always acts vertically downwards, right? Now, this force is acting at an angle of 60 degrees to the horizontal, and therefore it can be resolved into its components. It will have a component in the horizontal or the horizontally in the horizontal direction given by 40 cos 60 degrees, and it also has a component acting vertically of magnitude 40 sine of 60 degrees. So having done that, we can then proceed to calculating the acceleration of the body. Now, basically, they want us to find the acceleration of the body. So what we're told is that basically it is being pulled along smooth horizontal ground by means of a force of 40 newtons acting at 60 degrees above the horizontal, right? So it is being pulled along the ground, and therefore this horizontal component is the one which basically provides the acceleration. So we can say that horizontally, the resultant force Fr is equal to 40 cos of 60 degrees. Cos of 60 degrees, that is equal to a half. So a half of 40, this is equal to 20 newtons, right? And of course, by Newton's second law, we know the resultant force Fr is equal to mass times acceleration, and therefore this means that A is equal to the resultant force divided by the mass m. And so we get A is equal to 20 newtons. The body's mass, we are told, is 5 kilograms, and therefore this gives us 4 meters per second squared, right? So the acceleration on the body is 4 meters per second squared. Now, the second part of the question basically wants us to find the force the body exerts on the ground. Now, to find the force the body exerts on the ground, we'd have to consider what is happening in the vertical direction. And now let's examine the vertical forces. So we have the vertical force, the weight, mg, and of course we also have a component of the 40 Newton force acting vertically upwards of magnitude 40 sine 60. Now let's work out the magnitude of these two forces. First we'll work out the weight. So the weight of the object, W, is equal to mg, taking g as 10 newtons per kilogram, or 10, right? So W is equal to mg. So this gives us 5 times 10, which is 50 newtons. So the weight of the body is 50 newtons. Now let's work out this one, 40 sine 60. So 40 sine 60 degrees, that is equal to 40 times 0.866. And this basically gives us 40 times 0.866. So that gives us 34.6. This gives us 34.6 newtons, right? So in terms of the vertical direction, there is the body's weight always acting vertically downwards, and it therefore also means that, well, because the 40 Newton force is acting at 60 degrees to the horizontal, it also has a component acting vertically upwards, right? And therefore the force the body exerts on the ground will be the difference of these two, right? So therefore the force the body exerts on the ground is equal to the weight minus this component, and so that gives us, let's call this force Fg, force exerts on the ground, will be equal to 50 newtons minus 34.6 newtons, and this gives us 15.4 newtons. Right, so let's look at question 5. So question 5 says a railway truck of mass 6 tons moves with an acceleration of 0.05 meters per second squared down a track which is inclined to the horizontal at an angle alpha, where sine alpha equals 1 over 120. Find the resistance of the motion, assuming it is constant. So once again, we will try to represent the situation on a diagram. So we're told that a railway truck of mass 6 tons moves at an acceleration of 0.05 meters per second squared down a track. So basically what we have is an incline. And the railway truck is moving down the incline. All right? So let this be the truck. Right, so let that be the railway truck. So what are we told? It is moving down the incline with an acceleration of 0.05 meters per second squared. But before we put the acceleration, let's examine the forces acting on the truck. We always have the weight which acts vertically downwards, and we're told that the incline is an angle alpha. The angle alpha is such that sine alpha is equal to 1 over 120. So we're not given the angle, but we're given the sine of the angle, right? We're also told that there's a frictional force acting on the truck, right? Or resistance of motion. So if the truck is moving in this direction, in which is accelerating, then the resultant, or the friction, will be in the opposite direction. So let's call it the friction F, right? Now we're told that the railway truck is accelerating at a rate of 0.05 meters per second down a track. So this is the acceleration. A equals 0.05 meters per second squared. Now we've shown the weight acting on the truck. Now we could actually resolve its weight into its components, as this may be necessary. the weight will have a component perpendicular to the slope, and if this angle is alpha, this angle will also be equal to alpha, and this component will be mg cos alpha, right? Now the weight will also have a component parallel to the slope, and it will act along the slope in this direction, and this would be mg sine theta, right? So the weight has two components, one perpendicular to the slope and the other which is parallel to the slope, right? So the component parallel to the slope is mg sine theta. Good? Now, there's no mention of any other force acting on the railway track, and therefore these are the forces that we'll actually take into consideration, especially along the length of the plane. So let's consider the forces along the length of the plane. So the mass of the truck, of course, we're given is M is equal to 6 tons. 6 tons? Right, 6 tons, which of course is equal to 6,000 kilograms. Right? So we're given the acceleration 0.05 meters per second squared. So by Newton's second law, the resultant force Fr is equal to ma. And so this gives us 6,000 kgs times 0.05 meters per second squared. And so this gives us 300 newtons. So the resultant force along the slope or along the length of the plane is equal to 300 newtons. But let's examine the forces along the length of the plane. We have the component of the weight mg sine theta, which acts parallel to and down the plane, and we have the opposing force, the friction, right? So therefore what this also means is that the resultant force Fr is equal to mg sine theta minus the friction F, right? So having found the value of the resultant force Fr, we'll equate it to that, and we'll then solve for the unknown force, the friction. And so we have mg sine theta minus F is equal to 300. So we can now substitute the values of m and g and sine theta, and then we can proceed to solving for F. So m is 6,000, so we have 6,000 times 10, and since we're given the sine of the angle, so that is equal to 1 over 120, and this is minus F is equal to 300. So let's work this out. 6,000 times 10, that's 60,000 divided by 120. So that gives us 60,000 over 120 minus F is equal to 300, right? Zeros cancel, 12 into 60 goes 5. So this gives us 500. Make some space. So we get 500 minus F equals 300. And this therefore means that F is equal to 200 newtons. So the frictional force or the resistance to the truck's motion is equal to 200 newtons. So we look at another question. This time we look at question question 7. Now question 7 says, car of mass 1,000 kilograms tows a caravan of mass 600 kilograms up a road which rises 1 meter vertically for every 20 meter of its length. There are constant frictional force resistances of 200 newtons and 100 newton to the motion of the car and to the motion of the caravan respectively. The combination has an acceleration of 1.2 meters per second squared, with the engine exerting a constant driving force. Find A, the driving force, and B, the tension in the tow bar. So again, the first thing we do is to represent the situation on the diagram. So what we have here is a car which is towing a caravan up a road which rises up an incline, right? So let's represent that on the diagram. So we're going to let this be our incline, and the car is towing caravan. So let that be our car, and this our caravan. Alright, so that's our caravan. And of course, we'll include the forces acting on both vehicles. So for the car, front of the car look like the back. So, right, so good. So that's our situation there. Right? So what are we told? Car of mass 1,000 kilograms towards a caravan of mass 600 kilograms up a road rises 1 meter for every 20 meter of its length. So we're told that this road rises 1 meter for every 20 meter of its length. So if this is our angle theta, it would follow that sine theta is equal to 1 over 20. So the road rises 1 meter for every 20 meter of its length. And therefore sine theta, is it 20? Was it 20? Right, so road rises for every 1 meter for every 20 meter of its length. Good. Right? So what are we told again? We're told the combination has an acceleration of 1.2 meters per second squared. So there is an acceleration up the slope. So there's an acceleration up the slope, A equals 1.2 meters per second squared. Right? Now, we're told that the engine of the car exerts a constant driving force. So we're going to call that driving force FD. Right? Now, what are the other forces which are acting on these bodies? We are told that there is a frictional force of, or were we told that? Right. We're told that there are frictional resistances of 200 newtons and 100 newtons acting on the car and the caravan respectively. So right here, there is a frictional force of 200 newtons acting on the car. And there's also a frictional force of 100 newtons acting on the caravan. Right? Now, are there any other forces acting which may be important? The answer is yes. Right? We have the weight of the car acting vertically downwards. Let's call it small mg. Now, this weight will have a component which is perpendicular to the slope, and will also have a component which is parallel to the slope. So this would be parallel to the slope, and this weight or this component would be mg sine theta, right? So that would be mg sine theta. Similarly, the caravan will also have similar forces. So it will have this weight. Let's call the mass of the caravan m subscript c g, and it will also have a component perpendicular to the slope, and it will have a component parallel to the slope. And let's call that component parallel to the slope, well, mcg sine theta. Right? So essentially, these are the forces of interest which are acting on these two bodies. So for the car, we have the driving force Fd, and there's also a component of the weight acting down the slope and parallel to the slope mg sine theta. And there's also the frictional force of 200 newtons. For the caravan, there's its weight, of course, acting vertically downwards, and there's also the component acting parallel to and down the slope, and the frictional force of magnitude 100 newtons. So what are we asked to find? We're asked to find the driving force and the tension in the tow bar. So right where the tow bar is connected here, there has to be tension. So there's a tension, T. So our tension T, right? Now let's consider the bodies together, right? We know that there's an acceleration of 1.2 meters per second squared. Now the driving force is being provided by the engine, and of course the vehicle, the car, is pulling the caravan, right? So what we basically know is that the forward force, let's write it this way, the forward force minus the total resistive force is equal to the resultant force, or the mass times acceleration, right? So this is what is happening. So what is a forward force? There's only one forward force, which of course is the driving force, right? And so if we were to make the driving force the subject, then this basically means that the driving force Fd is equal to the total resistive force, or the total resistive forces plus mass by acceleration, right? So let's begin to work out our situation. So therefore the driving force Fd, now let's work out this part first. Now this M basically represents the combined mass of the car and the caravan, because what we're told is that they collectively together they accelerate at 1.2 meters per second squared. So this M not only represents the mass of the car or the mass of the caravan, but the combined masses, right? But we could actually work it out separately, but we'll just work them together, right? So that would be giving us, it's 600 plus 1,000 times the acceleration of 1.2, right? So that will give us the MA. Now, the resistive forces, of course, would be the 200 Newton and the 100 Newton frictional forces, and also the components of the vehicle's weight, which are acting down the slope, right? And so this will give us plus 200 newtons, or 200 plus 100, and for the caravan it would be mg sine theta. This is plus 600 times 10 times 1 over 20. And then for the car, it would be 1,000 times 10 times 1 over 20. And so if we work this all out, we get the driving force Fd is equal to 600 plus 1,000, that's 1,600 times 1.2, then that gives us 1920 newtons plus 300 plus, work this out, 10 times 600, 6,000 divided by 20, that's plus 300, and then 10 times 1,000, 10,000 divided by 20, then that gives us 500, so plus 500. And when you add that all up, 300 plus 200, 600 plus 500, 1,100, and so this gives us 3,020 newtons. So the driving force acting on the car is 3,020 newtons. The next part of the question wants us to calculate the tension in the tow bar. Now, to calculate the tension in the tow bar, for this case, we'll just focus on the forces acting on the caravan, right? So we're going to consider the forces acting on the caravan. Right? So we're going to focus on the forces acting on the caravan. Now the tension in the tow bar, it is basically equivalent to the force that's actually pulling the caravan. The opposing forces would be the 100 Newton friction and the component of the weight acting down the slope. So we can say that for the forces on the caravan, we can say that the tension minus some of the resistive forces, which is mg sine theta plus the friction, that is equal to the mass times acceleration. And therefore we can say that the tension T is equal to mg sine theta plus the frictional force plus the mass times acceleration. And once again, this gives us the mg sine theta for the caravan. From the previous part of the question, this would have been 600 times 10 times 1 over 20, which gave us 300. So this is 300 plus F, which is 100, plus of course the mass of the caravan, which is 600 times 1.2. So this gives us 400 plus 720, which gives us 1120 newtons. And so therefore the tension in the tow bar is 1120 newtons. So that was question 7. Now let's look at one of those questions in which we're dealing with friction, and in particular the coefficient of friction. All right, let's look at number 10. Number 10 says a particle of mass 4 kilograms is pulled along a rough horizontal surface by a string parallel to the surface. If the tension in the string is 20 newtons and the coefficient of friction between the particle and the plane is 0.2, find the acceleration of the particle. So again, let's represent the situation on a diagram. So we have an object which is being pulled along basically rough ground, because we're talking about the coefficient of friction, right? The mass, of course, is 4 kilograms. So the mass M is equal to 4 kgs. So we put the forces acting on the object, then the weight is acting vertically downwards, right? And tension in the string. So the string is parallel to the surface. So there is string which is pulling the object, and the tension in the string T is equal to 20 newtons, right? The coefficient of friction between the particle and the plane is 0.2, so that is coefficient of friction mu is equal to 0.20. Now there's a weight acting mg, there's also a reaction force R, right? So they want us to find the acceleration of the particle. Now, because there's a coefficient of friction, it also means that there will be a frictional force opposing the body's motion, right? And we must therefore work out that frictional force, right? So the relationship between the coefficient of friction and the frictional force is that basically we have F is equal to mu R, where R, of course, is equal to mg, but of course the normal reaction R is equal to mg, and so therefore F is equal to mu mg, right? So since we know the value of mu, the coefficient of friction, we know the mass, we can calculate the frictional force. So therefore F is equal to 0.2 times 4 times 10, and therefore F is equal to 8 newtons. So the frictional force F is equal to 8 newtons. And therefore, the resultant force, let's call it Fr. So the resultant force Fr would be equal to the tension minus the friction. So this is equal to T minus F. And that gives us 20 newtons minus 8 newtons, which is equal to 12 newtons. So the resultant force acting on this body or this particle is 12 newtons, but of course it has to find the acceleration, and so we can say the acceleration A is equal to the resultant force divided by the mass. And so therefore A is equal to 12 newtons divided by 4 kgs, which gives us 3 meters per second squared. Alright, so the acceleration of the body is 3 meters per second squared. Alright. Now we will look at another question which involves the coefficient of friction, number 11. So number 11 says, a particle of mass 8 kilograms slides down a rough plane which is inclined at, now the angle is given in terms of the sine inverse of a particular value, sine inverse of 1/6, so the horizontal. If the acceleration of the particle is 1 meter per second squared, find the coefficient of friction between the particle and the plane. So we have a plane and there's a particle sliding down the plane. Particle of weights mg. Now there's an angle theta to the horizontal, and of course you know the particle will have a component. This angle will also be theta, and this would be mg cos theta. It will have a component parallel and acting down the slope, and that will be mg sine theta. There will also be a frictional force, we call that F, right? And there will also be a reaction force R, right? So they want us to calculate the coefficient of friction. So the particle slides on the rough plane, and acceleration of the particle, the acceleration A, we're given basically as 1 meter per second squared, right? It's given as g over 10, but we'll just approximate that to being 1 meter per second squared since we're using g as 10, right? Now the angle is defined as, so theta is equal to the sine inverse of 1/6, which would therefore mean that sine theta is equal to 1/6, right? So the sine of the angle theta would be equal to 1/6. So it means that the vertical height would be 1, then the hypotenuse or the length of the ramp would basically be 6, right? All right, so let's examine the directions parallel to the slope. Now it is sliding downwards, and we're told it is, oh gosh, where's the question? Right, it is sliding down the slope with an acceleration of 1 meter per second squared. So there's acceleration A, 1 meter per second squared down the slope. So what we'll basically do is we'll consider the direction parallel to the slope and perpendicular to the slope, and we'll use those equations to solve for the coefficient of friction, right? So basically what we have is this. Let's look at the direction parallel to the slope. So parallel to the slope, the resultant force would be equal to mg sine theta minus F. So because the body is accelerating down the slope, and there's one force, the component mg sine theta acting down the slope, and there's a friction opposing the body's motion, it means mg sine theta must be greater than F, and the resultant force is going to be given by mg sine theta minus F. And so we have mg sine theta minus the frictional force, and that would be equal to the mass times acceleration, right? Now, what do we know from this value here? Do we know F? No, but we can find it, right? So we know the mass of the object. We're told that the particle is of mass 8 kilograms. So therefore M equals 8 kgs. So therefore we can solve for the frictional force F. If we bring this across, we get mg sine theta minus ma is equal to F. And so therefore F is equal to m, which is 8, times g, which is 10. Sine of theta is given as 1 over 6. So that's 1 over 6. Minus the mass by acceleration. So that is minus 8 times a, which is 1. And so this gives us 8 times 80. So this is 80 over 6 minus 8. Same thing as 40 over 3 minus 8. 40 over 3 minus 8. Yeah, 8, we can write 8 as, let's just leave it as a fraction for now. 40 over 3 minus 24 over 3. So this gives us 16 over 3. So the coefficient of friction is 16 over 3, sorry, the frictional force is 16 over 3, or approximately 5.33 newtons. So the frictional force F is equal to 5.33 newtons, right? Now we'll proceed to examine the direction perpendicular to the slope. So perpendicular to the slope. Now, because we're not told of any motion perpendicular to the slope, then basically what we must do is to assume that the forces are in equilibrium in that direction, and therefore the normal reaction R is equal to mg cos theta, right? So we're going to assume that acceleration equals 0, and so therefore this means that the resultant force along that direction is equal to 0. And so we can say that R minus mg cos theta is equal to 0, which therefore means that R is equal to mg cos theta. So that will allow us to find the reaction, and that therefore will then allow us to find the coefficient of friction. Now, do we know the value of theta? We could work it out though, because basically we could do it one of two ways. Let's just draw a little triangle here. Theta. We're told that sine theta is equal to 1 over 6. So this is 1, then this would be 6, and by Pythagoras' theorem, then this would be root of this squared minus that squared. This would be root of 35. We could leave it as root of 35, or we could just work it out using a decimal, right? So root of 35. Anyways, and it will therefore mean that cos theta is equal to the adjacent over hypotenuse, which would be root 35 over 6, right? And so let's now work out the normal reaction. So we can say now that R is equal to 8 times 10 times root 35 over 6, and let's just work that out. So 8 times 10 times root 35 equals divided by 6. So this gives us 78.99 newtons, right? But we know that, so we found the frictional force F and we found the normal reaction R. But of course we know that the relationship between the frictional force and the normal reaction is this. We say that F is equal to mu R, which therefore means that mu is equal to F over R. So this gives us 5.33 newtons divided by 78.9, and that should give us 0.07. So mu is equal to 0.07. So the coefficient of friction is equal to 0.07. And of course, as we can see, it is a pure number. It is a ratio of two forces, and therefore it's just a pure number. It has no units.